Tiny clawed tracks left in ancient mud are the oldest reptile footprints. Distinct clawed footprints found on a slab of 356 million year rock from Australia suggest that reptile relatives appeared between 35 million and 40 million years earlier than previously believed. The tracks also push back the origin of amniotes, a group that includes reptiles, birds, and mammals, and provide new evidence about how animals transitioned from existing solely in the seas to living on land.
Amniotes represent a crucial part of the transition from aquatic to terrestrial life, because they were the only tetrapods, or four-limbed creatures, that evolved to reproduce on land. Previously, the oldest body fossils and footprints associated with amniotes were dated to 318 million years ago in Canada, but the new findings, published on May 14th in the journal Nature, challenge such long-held assumptions and signal that the transformation of tetrapods living in water to living on land likely occurred much more rapidly than scientists thought. "I'm stunned," said study co-author Per-Erik Ahlberg, professor of evolution and developmental biology at Uppsala University in Sweden, in a statement. "A single track-bearing slab, which one person can lift, calls into question everything we thought we knew about when modern tetrapods evolved." The location of the discovery indicates that Australia, once a central part of the ancient southern supercontinent of Gondwana that also included present-day Africa, South America, Arabia, Madagascar, Antarctica, and India, may be the ideal place to look for more amniote and reptile fossils and where they originated, according to the study authors. Rewriting Evolutionary History: The Rock Slab, found by amateur paleontologists and study co-authors Craig Urey and John Eason in the Snowy Plains Formation in Victoria, Australia, appears to show two sets of tracks from the same animal that represent the earliest clawed footprints ever discovered. The shape of the feet is similar to a modern water monitor's, and though the animal's exact size is unknown, it may have resembled a small goanna-like creature about 80 centimeters 31 inches in length, said lead study author John Long, strategic professor in paleontology at Flinders University. Asian water monitors are large lizards native to South and Southeast Asia, while goannas are large lizards commonly found in Australia. Hooked claws, a key feature specific to reptiles, might have enabled the primitive tetrapod to dig and climb trees. The animal that made the footprints is the oldest known reptile and oldest known amniote, Ahlberg said, and it's helping scientists crack the code on how tetrapods evolved. "Our new find implies that the two main evolutionary lines leading to modern tetrapods, 1. the line to modern amphibians, and 2. the line leading to reptiles, mammals and birds, diverged from each other much earlier in time than previously thought, likely back in the Devonian period about 380 million years ago," Long said. Prior to this finding, the Devonian period was believed to be a time of primitive fish-like tetrapods and fishopods like Tiktaalik, which exhibited traits of fish and early tetrapods and began to explore shorelines in limited ways. But the new study reveals a diversity of large and small tetrapods, some aquatic and others largely or entirely terrestrial, likely lived at the same time. One of the implications of our research is that tetrapod diversity at this time was higher and included more advanced forms than had been thought, Ahlberg wrote in an email. "It's crucial to understand when life shifted from being entirely aquatic to terrestrial, because it is one of the biggest steps in the evolution of life," Long said. This transition showed that animals were no longer dependent on living in or near water. The transition occurred partly because amniotes evolved to reproduce with hard-shelled, rather than soft-shelled, eggs. The vertebrates move onto land was an important part, and within that a key step was the evolution of the amniotic egg. In the immediate common ancestors of reptiles and mammals, Ahlberg said, "So these events form a key episode in our own ancestry, as well as the history of the planet." The new study pushes the origin of amniotes much deeper into the Carboniferous period, 299 million to 359 million years ago, which allows a much greater length of time for the diversification of early reptiles, said Stuart Sumida, president of the Society of Vertebrate Paleontology and professor of biology at California State University, San Bernardino. Sumida, who wrote an accompanying article to release with the study, did not participate in the new research. The search for amniote origins long has been studying ancient fish fossils from the Mansfield district, where the slab was found, since 1980. The Mansfield area has produced many famous fossils, beginning with spectacular fossil fishes found 120 years ago, and ancient sharks. But the holy grail that we were always looking for was evidence of land animals, or tetrapods. Like early amphibians, many had searched for such trackways, but never found them, until this slab arrived in our laboratory to be studied, he said. Fossils from the Mansfield district have shed light on how sexual organs might have first evolved in ancient armored fish. Now, the researchers want to know what else lived in Gondwana alongside the ancient reptile they found. The findings have inspired researchers to broaden the search for fossils of the earliest amniotes and their close relatives to the southern continents, Sumida said. Most of the skeletal fossil discoveries of the earliest amniotes are known from continents derived from the northern components of Pangaea, Sumida said in an email. Discoveries there suggested that amniote origins might be in those regions. It seems clear to me now that we must now expand our search for early Carboniferous localities in Australia, South America, and Africa.